Welcome. We're going to go over 215 and 216, so let's do it. We're getting to the end of this little packet here. Suppose on a hypothesis test for a single population mean, we have a mu of h sub a, mu less than 10, and they don't tell us h sub o. Now, assuming that we find out h sub a is true, so that ends up being our truth. We know mu is a number less than 10. For a fixed sample, so they won't tell us what n is, but it's fixed, we can't change it, and for a fixed level of significance level, so we can't change it, it's fixed. Let's say, what would be the power of the test? How could we make the power of the test the greatest if the actual mean was which one? So the power is our ability to detect an untruth. So notice here, we say over and over again to increase power, so it's great review, to increase power, we can increase n, because that's going to help us find an untruth, is just take more samples. Or we can increase the significance level. Sometimes we can't do that, but that would also work. Increase alpha, significance test, or the significance level. And so here it's saying, nope, can't do that either. We fixed those. So how else could we increase the power of the test? Well, your best ability to detect it would be if it's the furthest away from that. And so here, if h sub o was 10, it's going to be pretty hard. If it was 10, it's going to be pretty hard to say that it's something less than 10, because that would be like 0.9999. And we said this is in fact true. So we're looking for which number is the furthest away, because that's going to make it the easiest on us to detect an error. And we're saying, yes, assume that an error was made when they set this h sub o. So notice, if h sub o, we know it has to be less than, so it can't even be 11, because you said h sub a is true. So if h sub a is true, you had to have set an h sub o, and mu naught was something less than 10. So this is the furthest away from the number 10, and that's your best chance at detecting an untruth, is that your h sub o was as far off as possible. That would increase the power of the test. So that's our choice for 215. Now let's take a look at 216. Once again, we're looking at a residual plot. So a residual plot is used when we're trying to detect whether or not a linear relationship is the most appropriate. So once again, if we see a pattern, we must say that a linear relationship is not appropriate. Now we can do other things to this graph. We can do the log of x or the log of y, and then see if there's a pattern. But based on the least squared regression line, when we zoom in on the least squared regression line and we see a pattern, we say to ourselves, nope, a linear relationship is not appropriate. Here I see another pattern, not appropriate. I do kind of see a pattern here where the residuals are further away at the beginning and get much more accurate or much closer to the line toward the end. And the opposite is true for this one. So C is going to be the most appropriate answer because it looks the most random. Or you could say there's the least amount of pattern here, kind of working backwards. I think most folks got that right. Thanks for joining us.